Hello, programming languages students. Welcome back to another Prolog video. This one isn't as dependent on the other videos. It's kind of its own thing once we've covered variables, but it is useful information. And I think there's an example of complex predicates, essentially complex statements, and also anonymous variables. And I think even more common than these complex statements is the usage of anonymous variables. So pay special attention to that part. I mostly have complex statements here just to give you an interesting example about how Prolog can be used, and also an example where anonymous variables make sense. So we have here vertical a vertical predicate which has line as a predicate inside of a predicate. This makes it complex. And then inside of line it takes 2 points, and each point has two variables, x and y here, x and z here. So what is this trying to say? Well, to translate, what we're trying to say is we have a line um, that's composed of 2 points, right? Lines can, as long as you have 2 points, you can draw a line. So we're going to make a line. It's going to be composed of 2 points. The first point can be any values you want, x and y, and it's going to unify our variables. Whatever number we give first will unify with x. The second number will unify with y. And then it has another point, and the key thing here is the x is the same, and the z is a different variable. So if we're drawing a line that has two of the same x values and two different y values, well, what does that tell us about the line? It tells us it's going to be vertical. So if you think about a plot, think about this whole window as a plot. If x equals 1, and let's say we're here, then no matter what y equals, all the points in that line would be vertical, right? So we have a vertical line if the x values are the same, but the y values are different. That's what this is trying to say. And then we have a horizontal line if it's composed of 2 points where the x values change, so our horizontal values change, but our vertical y value stays the same. So if y were, I don't know, an imaginary 3 here, we could set x to whatever we want, and all those lines are going to be horizontal. All right, so that's the idea. And the way this is defined is we have nested, it's basically nested predicates, which this is called a complex statement, and we're probably not going to use them too much, but it's really helpful to express some ideas here. So let's do vertical line point. Let's do 2 and 3 and point 3, 4. So the idea behind this query is we want to check if we can make a vertical line using the 0.23 and the 0.34. So if x is 2, y is 3, and if x is 3, y is 4, are these vertical? The answer is no, they're diagonal. And we get false. We get a couple warnings here, and this is maybe the more important piece of this, is these warnings. And I'll talk about what they're doing in a second here. But first I want to point out, if we did want to make this return true, any value with an x of 2, an x that matches the first x here, will return true. So this is a good way to check for vertical lines. Are these 2 points vertical or not? We could check for horizontal. If we had a point 3, 3 and a point 7, 3, so x equals 3, y equals 3, and x equals 7, y equals 3, these would be horizontally in line, so this returns true. But these really annoying singleton variable warnings are there. So why are we getting warnings? Well, if we look back up here, we use y once in this statement. That means y could literally be anything. And we use z once. Z could literally be anything. There's no other z's in the statement. There's no other y's in the statement. So these are basically meaningless. These are anonymous variables. They could be any number you want. It's kind of the point, right? We want an x that we care about. That's why these two x's match. That's why we don't get the warning on these x's, is that there are two x's. So this adds a constraint to our problem. But putting y here and putting z here don't put any constraints on our problem here. They can literally be anything. And so there's a special way to handle this in Prolog, which is to use an underscore. And this is called the anonymous variable. Variables can start with capital letters or underscores, and a single underscore gives us an anonymous variable, which means I don't care what's here, and I don't need to track it. Right? If we give it a variable name with a capital letter, or an underscore and then a name after it. We're giving a specific variable name. But in Prolog, the underscore means there needs to be a value here, but I want to put no restrictions on that value. It can be whatever it wants. And what it leads to is a little bit clearer code, right? So if we look at this, vertical line has a point x plus whatever, and another point x plus whatever. A horizontal line has a point whatever comma y, and another point whatever comma y. So as long as the y values are the same here, or the x values are the same here, in this case we have a vertical line, in this case we have a horizontal line. So the anonymous variable says we need to have a spot, we need to have a value here, but we don't care what actual value is put there. So now if we run this, we don't get any more warnings. This is good coding practice. Um, and as you write functions, you'll find points where you don't care what values here. Instead, you just want to match specific values as you go along. Before I let you go at the end of this video, though, one quick little interesting highlight, maybe a couple interesting highlights. Let's say we have point 33, and let's see what happens if we start throwing variables in here. What can Prolog tell us? So first of all, we're looking for horizontal, right? So we don't care what the x values are, but the y values have to be the same. And so we start with a 0.33, and we want to know if we have a point with an x value of 7, and actually let me make this y, so it's a little bit more clear. What y value would we need to make this match? And so the answer is 3, right? Let's try something else. Let's say that we set y equal to 3, and we said which x values will make this true. Well, it just says true. The reason it says true is because, well, any x value would make this work, right? What happens if we do x and y? Well, just y equals 3 pops up, right? So it's pretty smart here. It's saying that I don't care what the x value is. It can be anything. It's just true. The y value, though, has to be specifically 3. Let's take one more leap here, and then we'll be done. All right, so this is the really interesting part. What happens if instead of giving it a point at all, we just say p? So we give it a variable here. So what point or what thing put here would make this true? This is the really interesting part. It says in order for this statement to be true, p would have to be replaced with or unified with point, right? So we'd have to make p a point. Oops, what did I do? All right, we have to make p a point, and this is the really interesting part. P would have to be a point with underscore 1452, comma 3. Well, the comma 3 makes sense, right? If I want a horizontal line and I have a 0.33, my other point has to be something 3, but we don't care about what this value is. So you'll notice that what actually prints out here, variables can start with capital letters or underscores. This is just a variable. I don't know why they chose 1452. The reasons behind it I don't know. But the key is this is a variable. So it's saying that any variable value here would work as long as it's a point that ends in 3. So Prolog is actually able to go backtrack and take all the potential logic here and figure out that to make this statement true, you would need a point with any x value and a y value of 3. So if you ever see this show up in any of your printouts here, what Prolog is saying is there's no restrictions and no restraints on this variable. It can be whatever value you want it to be. So keep that in mind if you see this pop up in the future. Hopefully that makes sense, and if you have questions, let me know.